Alright, so I have my truss here. It has 5 joints and it has B, A, C, D, and E. We have forces going down at A at 250, C at 1000, D at 250, and then we have both a pinned support and a roller support. The distances are from B to A are going to be 10 meters, A to C 15, C to D 15, D to E, I don't know why I wrote 15, that's supposed to be 10, and then E to B is going to be 30. So this is the truss, and for the first step for solving it, I'm going to need to just check if it's statically determined, and the formula for to see if it's statically determined is going to be 2J equals M plus R, and what this is just saying is going to be 2 times the number of joints, which in this one is going to be 5, equals the number of members, which is these lines, which is in this one is 7, plus the support reactions, which is 3 for this one. And that checks out. It equals 10. So we have that. So we know it's statically determined, so we can go on to step 1, which is solving the angles. And for both these two angles, we know that these are both 90, which we will use later in the angles, but first we're going to be able to find this angle right here by using the tangent of -1, and then opposite over adjacent from this spot right here, which will be 10 over 15. And then I just gotta plug this into the calculator. And it's going to be about 33.7. And that's going to be this angle right here, 33.7. And then from that we can get this angle right here, because we know that all of these angles have to add up to 180. So if we do this 33 plus 90, which is going to give us 123.7, and then subtract that from 180, it will give us our last angle, which will be 53.3. Sorry, I did that wrong. 56.3. 56.3. And then, since that will actually, because of that, we can fill in most of our other angles. Because, so we can know that this is going to be 33.7. This one's also going to be 33.7. This one's going to be 56.3. This is going to be another 33.7. And then for this last angle, we can do 33.7 plus 33.7. And then subtract that from 180, which will give us, because this straight line is 180 degrees, so we can do 33.7 plus 33.7, and then subtract that from 180, which is just going to give us 112.6 about, and then that is our final angle. And then now that we have all of our angles, you can see right here, I just did the tan of -1 to get this. Then from that, I was able to do some addition and subtraction to get this one, fill in the rest of them, and then just do addition to get this one. After angles, I'm going to go into outside forces. Then for our outside forces, we have outside forces in the X and outside forces in the Y direction, and they will both add up to 0. So we only have one one force in the x direction going this way currently, or outside forces. So we know that B, it has to equal 0 because it's the only force there. But we have a bunch of forces for y. We have A, B, C, D, and E. And for this, we have negative 250 at A. We don't know at B, but we know we have one. At C, we have negative 1,000. And at D, we have negative 250. But we don't know at E. And so for this, we're going to have to go into moments. So I'm just going to write that right here. So we got moments right there. And moments is basically going to be from the pinned support, the x direction, plus the force that's on there is going to equal the moments. But moments will also add up to 0. So m equals 0. So everything has a moment, so we're just going to start with moment in A. So we got a moment in every direction. And for A, since A is going to be also, and it doesn't have anything in the x direction going up, A is going to be 0 times 250, which is just going to equal 0. For B, it's a similar boat. It's going to be 0, but we don't know times what because we don't know what force is at B. But we just know that's going to equal 0 because anything times 0 is 0. Next, we're going into C. And for C, we know that it's going to be 15 because 15 right here. And then it's going to be 15 times negative 1,000. Which if we plug that into the calculator, it's going to give us negative 15,000. 15,000. And then for D, we're going all the way across, and which is going to be times negative 250, which is going to give us, let me put in the calculator, 7,500, negative 7,500. Sorry, it's kind of hard to see. I put it, oh, sorry. It's right there, though. And then for this one, we know that it's also, for E, we know it's also going to be 30, but we don't know times what. But we do know from all of this, since this is the last one we left, we can do these two numbers, 15,000 plus 7,500, and we get 22,500. And since these are both negative, and since these two are 0, that this for this to all equal 0, let me just, this has to add to 0. This is going to have to be 2,000 or 22,500. And then to get the force, we can divide this 22,000 we just got by 30, which is going to give us 750. And then so you can see that I go plug E over here now, back into the outside forces. We know that E is going to be 750 from this. And then since this also has to all add up to 0, we can just subtract 750 from what we have here, which is going to be 1,500. And we know that this that B also has to equal 750. Okay, so now that we have got that done, we now have gotten all our outside forces done. I can even add them into here. 0, 750, another 750 over here. So we have all of our angles, all our outside forces. We can flip over and start on to member forces. But first, I'm going to build a little. I don't know what you would call it, but it basically just shows what the forces and stuff. We have for all the angles. Sorry, it's not the best, but you get that each of the points has like the where it is going off, where the members are shooting off from it, you know. So I'm going to start off with a joint A. There's joint A. Oh, sorry, I should probably... You were looking at this sideways. This is just to give you a good look at all the work that I've done so far in case you want to look over it. And then, so we're going to be starting at joint A, which is I'm just going to do a simple diagram of it. It looks like this, and it has a force going down at 250. And that's basically all we know. But to solve the joint, we're going to do the same thing that we did for finding outside forces. We're going to have forces in the x and forces in the y. This one is going to start out, it's going to be very simple. We only have one force in the x direction, which is going to be A to C. So AC, it's going to equal 0. And then for the y, we have 2. We have A, and then we have AB. And since A is going to be negative 250 because it's going down, that to counteract that, to make it equal 0, that this is just going to have to be 250. So AB is 250. So this joint is solved. Going on to another joint, we're going to be going on to joint B. And for joint B, I'm going to draw it out. So this is our joint B. We have A, C, and E over here. And then going to do the same thing. Forces in the X. And, we have a few more ones in the X direction. We're going to have B, because, B was a pinned support, so it has 2 directions going on it. We also have B, E. But we're also going to have BCX, because when you're dealing with diagonals, you have to break them down into BCX and BCY. So this would be BCX right here. I'm also going to put this angle in because we will need that for later. This one is 56.3. 56.3, and then for y direction, we're going to have just B again. B, BA, because BA is going that way, which is Y. And then BCY, which is going to be right here as well. And we're just going to start with filling out the things that we know. We know B is 0. We know that BA is going to be negative 250, which you might be looking at this and think that how could it be negative 250, because this one says 250, but since we're switching around, it's not AB, it's BA, switches it to negative 250. And we also know that just at B is going to be 750 pushing up. And so from that, we can, since all of these has to add up to 0, we know that 750 minus 250 is 500, so we can just get that 500, and now we have all of the ones in the y direction solved, but not all of the ones over at x solved. But to get x, we can find BCX by using BCY. So we can solve this by using the tangent of this angle right here, because see, it goes across and down, and this is like the angle that's in there. The tangent of 56.3 times negative 5. Or if I make this a negative, that was my bad. Times the negative 500. is going to give you, actually let's plug it into the calculator, tangent of is going to give you about negative 750. Wait, let me check something real quick. So it's about, as you can see right there, it's like it's close enough. It'd be 749.7, but I'm just gonna round it up to 750 because it makes things simpler. So this is gonna be negative 75, and since all this has to add up to 0, we know that BE is going to be 750. But we're not done yet, even though we haven't found a B to C directly yet. But to find a B to C, we can use this formula where we will find the square root of and it doesn't matter if it's negative or positive because we're squaring it. So we're going to do the square root of 750, which is going to be BCX squared, plus the square root, not the square root, plus 500 squared. Let me plug that into the calculator. Second square root, 750 squared plus, it's going to give us about 901. So 901. And then we're going to go up here and put that in here, 901. And I forgot to do this for joint A, but we can also plug in the ones we got for joint A. So AC is going to be 0. And AB, which is, oh, I forgot to put even, sorry, I'm going to put in the words for this. Okay, and AB is going to be 250. And then we've also found out, because of this right here, BE is going to be 750. So we know all of these. And then, but we still have some more joints to do. So we're going to flip over, and we're going to do, oh, I can't flip over to that side, my bad. I'm going to flip pages, and I'm going to do joint D, which is going to be very similar to what joint A was. It's going to do a little diagram of it. It's going to be a force going down at 250 on D, obviously. And so we're just going to do the same thing. We're going to do X, Y, force in the X direction, forces in the Y direction. And same thing again, there's only one force, which is going to be DC, so it has to equal 0. And for this one, D, and then DE, and then so we already know this one's going to be negative 250. So that means DE is going to have to equal positive 250 for it to add up to the 0 that we need. And from that, we can also go back to this thing right here, and we can fill in the new numbers that we got. 0 and 250. Now all we have is this to find out. I'm going to be using joint E to get there, so gotta flip. Which one? Okay, and here. So I'm going to be using joint E. Joint E is also very similar to joint B. We're going to have E, D, C, and B. And then similarly, we're going to be using an angle again. We could write in this angle as well, but we don't need to, it being 56.3. Well, we're not going to be using that angle in this one. So now that we have all of that filled out, we're going to do our x's and y's. Need some more lead. Okay, and so for x's, our x directions, since this is not a pin support, this is just a roller support, it's just going to have a force going up against it, which we know, but we're not going to have an x direction or an extra x direction like we did in member B with the pin support. So we're going to have EB and ECX. So we don't know ECX, but we do know EB, which is because it's going to be just the opposite of what it was across. So it's going to be negative 750. And then for y's, we got some more on the y's. We have just E, which we know to be 750. We're going to have ED, which we also know to be negative 250 because it's the DE, it's going to be flipped because it's ED. And then we have ECY. And we're going to be using, to find E to C, we're going to be using this as our X and this as our Y. Okay, so it's pretty simple to find this. We could actually just use, since they both add up to 0, we could just fill them in pretty simple, but I want to use tangent again just to show some more work with it. So I'm just going to be filling in one of them. I'm going to be filling in this one as a 750, we know that. But now we can use the tangent of our angle right here, 33.7, and then multiply that by our 750, and that's going to give us our ECY. So tangent of 33.7 times 750, and that's going to give us about 500. If you can see there, it's about 500.1, but it's about 500. So we have our 500 for right there, and that gives us the ability to use the same formula we used last time, which is going to be the square root of 750 squared plus 500 squared, which is basically the same equation. I'm pretty sure it is exactly the same equation if I check. Yeah, so I'll just plug it in again just to be sure. So the square root of 750 squared plus 500 squared. It's still basically it is the same number, but I'm just gonna write it as 901. And as I flip back over to this, we can see that this is 901, and we're not finished yet. We need to see if these are in compression or tension, and it's going to be the opposite. So if this was being pushed on, it would have arrows pointing out because it needs to push out to resist the force of it being pushed in. And so we will do that. These ones are going to have to be pushing apart because they're being pushed in. Same with these ones. They're going to have to be, because they're not pushing apart, they're being pushed in, so they have to resist by pushing out. If that makes sense. Going to be the same thing here. You get a good look at that. And then for last, this one is actually going to be going in because this is pulling out, so it needs to pull itself back in. And that is about it, but I will just quickly go through each step that we did, but I'm going to be showing it this way because I know it might be hard to read it other ways. So we have our truss right here that we had the original. We had our three forces we knew about and our distances, which was 10, 15, 15, 10, and 30. And then from that, we had to check if it was statically determinate using 2j equals m plus r. We did that. We got our 10. 10 equals 10. Then we went on to angles, and we used the tangent of -1 times opposite over adjacent, which for this one is going to be 10 over 15. And we got our 33.7, and from that we were able to use addition and then subtract by adding it to 90 and then subtracting it from 180 to get this one, 56.3. And then from that, since a lot of these distances are similar, we were able to fill in 33.7 right here, and this one, all except for this angle, which we had to use 33.7 plus 33.7 minus 180 because this straight line is 180. And we were able to get that angle. Then from that, we went on to outside forces, which we used all the forces like pushing in on the truss from the x and y direction. We only have one from the x, so it has to be 0. We did not have b or e. We only had -250, -1000, -250. And so we were not able to find out what our other forces were. So then we had to go into moments right here, where moments are from the, not roller truss, from the stationary truss, pin support, not truss, from the pin support in the x direction, which it wouldn't always be in the x direction. If this was facing like this way, it'd be in the y direction. But since it's facing this way, it's going in the x direction. So the distance in the x direction times the force on it is going to be the moment. And so we're able to use that to fill in. The first two are both on it, so it's going to be 0. So 0 times anything is going to be 0. So able to find this one and this one both being 0. Then we went on to C. And since C is going to be 15 and then 1,000 down, we did 15 times -1,000, which is the force that is going down on it. And then MD is going to be all the way across, so 30 times -250, which is going to give us -7,500. And then for this one, we do not know we know how the distance, which is 30, but we do not know the force on E yet. But we do know that it's going to have to be 22,500 because it's the only force left, and they all have to add up to 0. And so once we get that, we can divide it by this 30 to get 750 to find this in the y direction. And since we only had one y direction left, we could do 1,500 minus this 750 that we just got to get another 750 to complete all of our outside forces. And then we flipped over and then we built this thing before going into member forces. This basically just shows the member forces in between each of them. So we start off with joint A, very simple, x direction, y direction. We only had one real force on it, and since we could just do negative of that and get, and this one was just 1, so it had to be 0. Then we had this one, which was a bit more complicated. We were able to just fill in this one because we already had the 750 and the -250, so we knew this had to be -500. And then we could use that and through this angle right here, because it has to be in the x and y, to get the tangent of 56.3 times -500 to get 750, and then we were able to plug that into this equation, which is going to be square root of both of them squared, and that gave us this 901 for this, and we plugged our stuff into here. Then we flip the page, go on to joint D, which is going to be, again, very similar to joint A, and we just x, y, only one in the x direction, so it has to be 0. Same thing with the -250, so the other one has to be 250. Then we go on to joint E, which is our last joint. Also very similar to joint B. So, but we didn't have to do this time because we had enough to we could have just filled all of them in because there was only one left on either of them. But I just wanted to get some more work with using tangent. So first we just filled in this one to get this 700, and then we used the tan of this angle right here because it's going across and up to get 33.7 times the 750 to get our 500, and then we do the exact same thing, very similar, square root of both of them, which is the exact same equation, so it gives us about 901. And then we can go back and plug it in to here. And then we just did see if they were in compression or tension, which you see I've done. Sorry, I did this one kind of backwards. It is, I don't know why, that just looks weird. It needs to be going out like that, though. That was my bad. But you can see I fixed it, and yeah, I'm just gonna show you like kind of like the full page on each of them real quick in case you maybe missed anything and want to look back, or I don't know, maybe I missed something. It could have been hard to see while I was doing it sideways, so this is just it, and that's the whole truss. Thanks for watching. Bye.